Hey guys, this lesson talks about solving and graphing inequalities. Just a quick reminder, here are our inequality symbols. If it has the line underneath, it is less than or equal to or greater than or equal to. We have one property I want to discuss. It's called the transitive property for inequalities. So if A is less than B and we have B less than C, then we can skip that B middle step and just say that A is also less than C. We're going to look at graphing. So here's an example. We have x is greater than 1. We graph on a number line. So here is the value x equals 1. Greater than would mean anything to the right. And since it's not equal to, we have to have an open circle because it cannot be equal or touching the value 1. Here's another one. X is less than or equal to 4. So again, we go over to 4 on our number line. It can be equal to, so we fill our circle in, and then less than would be anything to the left. I'd like you guys to tell me what inequality represents this graph. Okay, when we graph, remember that if it's less than or greater than, we will have an open circle, and if it has the equal to sign underneath, it will be a closed circle. We can go ahead and solve some inequalities and then go ahead and graph them as well. So if we have x plus 6 is less than 7, we can subtract 6 from both sides just like we would in an equation, and we get x is less than 1. And here's our graph for that. Here's another one that's a little more complicated, a few more steps. So I went ahead and distributed our, just kidding, I'm sorry, I divided by -2 first. When you divide by a negative in inequalities, you have to make sure that you flip your sign. So this becomes 4 plus b on the left side. This inequality sign flips to be greater than or equal to, and then 4 divided by -2 is -2. Okay, now we can solve this like a regular equation, subtract 4 from both sides, and we get b is greater than or equal to -6. And there's your graph for that. I'd like you to solve 3y plus 2 is greater than 8. Okay, we're going to talk about a couple special cases. So here's our original inequality. I'm going to go ahead and distribute on the left side, so I get -2x minus 6. My goal is still to solve for x, so I'm going to add 2x from this side over. That leaves me with a -6 on the left and a +1 on the right. There's no variables, so that's why it's a special case. -6 is indeed less than 1, so it's a true statement, which means our solution set is all real numbers. Remember, this is the symbol for all real numbers, but kind of what this means is you could choose any x value, any real number x value, plug it in, and it will satisfy this inequality. Another special case comes from this example. So again, I'm going to distribute on the right side. So on the right side, it becomes 3 plus 4b minus 4. I'm going to go ahead and combine our constants on the right. So we have 4b is less than -1 plus 4b. And then I'm going to subtract this 4b to the left. That leaves me with 0 on the left side and -1. 0 is not less than -1, therefore it is false. And our solution set is just no solution. No x value, or in this case b value, will make this inequality true. Okay, we're going to have compound inequalities, so that means we have 2 of them. We have 4x minus 10 greater than or equal to -2, and 4x minus 10 is less than or equal to 10. So what we're going to do here is solve each of these individually. We're going to add 10 to both sides, and then add 10 to both sides here. So the left becomes 4x greater than or equal to 8. The right inequality is 4x is less than or equal to 20. Divide both by 4. We get x is greater than or equal to 2 and x is less than or equal to 5. We want to write that as a compound inequality. So remember, your smallest number always will go on the left, and you will have 2 less than or equal to signs with the x in the middle. This one, a lot of people think we have to switch our sign, but in reality, if we read from our variable first back to the left, we have x is greater than or equal to 2, which is exactly what this says. Okay, and then from x over to the right, we have x is less than or equal to 5, which is also what that inequality says. And then our graph, both closed circles and our arrows point together. Please solve this compound inequality.